Imagine waking up on a seemingly normal day in September 2182. The sun rises, birds chirp, and life goes on as usual. But high above, hurtling through the vast emptiness of space, a monstrous chunk of rock is on a collision course with Earth. Its name, Bennu, its mission, potential annihilation of life as we know it. This isn't science fiction. This isn't some far-fetched doomsday prediction. This is real. This is the future that NASA scientists are warning us about. Asteroid Bennu, a behemoth space rock bigger than the Empire State Building, has a rendezvous with Earth, and the date is set, September 24th, 2182. Now, you might be thinking, that's over 160 years away. Why should I care? But here's the terrifying truth. The decisions we make today, the actions we take in the coming decades, could determine whether humanity survives this cosmic game of chicken. Let's break down the facts, shall we? Bennu is what scientists call a potentially hazardous asteroid, or PHA. Discovered in 1999, this space rock is about 1,614 feet or 492 meters in diameter. That's roughly the height of 5 Statues of Liberty stacked on top of each other. It orbits the Sun every 1.2 years, and every 6 years it comes frighteningly close to Earth. But it's not just Bennu's size that makes it a threat. It's also its composition. Unlike some asteroids that are essentially loose piles of rubble held together by gravity, Bennu is a solid chunk of rock. This means that if it were to enter Earth's atmosphere, it wouldn't break apart easily. Instead, it would barrel through, unleashing devastation on an unimaginable scale. The energy released by Bennu's impact would be equivalent to 1,200 megatons of TNT. For comparison, the most powerful nuclear weapon ever detonated, the Tsar Bomba, had a yield of 50 megatons. Bennu would be 24 times more powerful. The explosion would create a crater several miles wide and trigger earthquakes, tsunamis and firestorms that would ravage the planet. But the immediate destruction would be just the beginning. The impact would throw millions of tons of dust and debris into the atmosphere, blocking out the sun and plunging the Earth into a prolonged period of darkness and cold, an impact winter. Crops would fail, ecosystems would collapse, and billions could die from starvation and conflict over dwindling resources. But here's where it gets even more unsettling. The more we study Bennu, the more we realize how unpredictable its path can be. You see, Bennu is affected by something called the Yarkovsky effect. As it rotates and its surface is heated by the sun, it releases this heat as it spins. This creates a tiny thrust that, over time, can significantly alter the asteroid's trajectory. It's like trying to predict the path of a leaf caught in a gust of wind, except this leaf is the size of a skyscraper and moving at 63,000 miles per hour. Even a minuscule change in its path now could mean the difference between a near miss and a direct hit in 2182. And let's not forget about Earth's gravity. Every time Bennu passes close to our planet, there's a chance that our gravitational pull could nudge it onto a collision course. It's like a cosmic game of billiards, with Earth and Bennu as the balls, and the fate of humanity hanging in the balance. But wait, there's more. Bennu isn't just a threat because of its potential impact. It's also a ticking time bomb of ancient solar system history. You see, Bennu is what scientists call a carbonaceous asteroid. It's chock full of carbon-based compounds, including some of the building blocks of life. In fact, NASA's OSIRIS-REx mission, which visited Bennu in 2020, found evidence of organic molecules and even water on the asteroid's surface. Under different circumstances, this would be an exciting discovery, but in the context of a potential impact, it's terrifying. An impact from Bennu wouldn't just devastate the Earth through sheer force. It could also introduce alien organic compounds into our biosphere, with unpredictable and potentially catastrophic consequences. One proposed solution is what's known as a gravity tractor. The idea is to send a spacecraft to fly alongside Bennu for years, using its own tiny gravitational pull to gradually tug the asteroid off its collision course. It's a bit like trying to steer a cruise ship by tying a rowboat to its side. It would take a long time, but it might just work. Another option is the kinetic impact method. This involves smashing a spacecraft into Bennu at high speed, hoping to knock it off course. NASA's DART mission, which successfully altered the orbit of the asteroid Dimorphos in 2022, proved that this concept can work. But Bennu is much larger than Dimorphos, and we'd need to launch such a mission decades before the potential impact to have any chance of success. There's also the nuclear option, literally. The idea would be to detonate a nuclear device near Bennu, not to blow it up, which could create multiple smaller impactors, but to use the explosion's energy to push it off course. It's a risky plan, fraught with technical and political challenges, but it might be our last resort if other methods fail. But here's the catch. All of these methods require time, lots of time. We're talking decades of planning, testing and execution. And remember, we're not just dealing with Bennu. There are thousands of other potentially hazardous asteroids out there, many of which we haven't even discovered yet. We're playing a cosmic game of whack-a-mole, and we're woefully unprepared. So why aren't we doing more? Why isn't this threat plastered across every newspaper, discussed in every classroom, debated in every government? The answer, ironically, might lie in the very thing that makes Bennu so dangerous time. You see, human beings are notoriously bad at dealing with long-term threats. We are wired to respond to immediate dangers. The tiger in the bush, the car speeding towards us, but a threat that won't materialize for over a century? Our brains simply aren't equipped to process that kind of timeline. But make no mistake, the clock is ticking. Every day that passes without action brings us one day closer to a potential impact. And while 2182 might seem far off, consider this: the time between now and the potential Bennu impact is about the same as the time between now and the American Civil War. In cosmic terms, it's the blink of an eye. And let's not forget the broader implications of this threat. Bennu is just one asteroid among many. Its potential impact in 2182 is a wake-up call, a cosmic alarm bell warning us of our vulnerability. Today it's Bennu, but tomorrow it could be another asteroid or a comet or some other celestial body we haven't even discovered yet. The harsh reality is this: we are a species living on a cosmic shooting gallery, and our defenses are woefully inadequate. We've spent trillions on weapons to protect ourselves from each other, but comparatively little on protecting ourselves from threats from space. It's time for that to change. So what can we do? As individuals, we can raise awareness, support scientific research, and push our leaders to take this threat seriously. We need increased funding for asteroid detection and deflection technologies. We need international cooperation to create a global planetary defense strategy. And we need to start now. Because here's the truth we've been grappling with. While the exact probability of impact remains uncertain, the potential consequences are too catastrophic to ignore. NASA's calculations show a real and significant risk. Every passing day without action increases the chance that September 24th, 2182 could mark the end of life as we know it. The time to act is now.